Okay, this is an example of rotating an area about the x-axis to create a volume of revolution. So I'm just going to do y equals 2x plus 1. So we'll keep it nice and straightforward. We're just going to do something like that. And we can look at rotating the area bounded by x equals 1, x equals 4, the line, so y equals 2x plus 1, and the x-axis. And we're going to rotate to start with about the x-axis. So the formula for this volume of revolution is equal to pi, the integral of y squared dx. So I want to integrate between 4 and 1. Y is equal to 2x plus 1, so y squared is 2x plus 1 squared. And then we can integrate functions of x with respect to x. You should be okay from there, multiplying out that bracket. You get 4x squared plus 4x plus 1. And then integrating, so you can just keep this pi on the outside, you don't have to incorporate it in. It actually makes life a little bit easier. So you get 4 over 3 x cubed, raising the power by 1, dividing by the new power. You don't need to plus c because we're between limits, between 4 and 1. So that is equal to, sorry, I've got it here somewhere. So it's pi lots of 364 over 3, plugging in x equals 4, minus 13 over 3, feeding through x equals 1, and that gives you 117 pi. So these volumes of revolution will be in terms of pi. Don't worry too much about units as per normal. So you're going to create a sort of bowl shape that's coming round like this as it spins around the x-axis. I'm also going to spin the same curve about the y-axis. Only I just want to show you the algebra really and how to deal with it. So same principle. So there's my y equals 2x plus 1. And we're going to rotate the area bounded by y equals 2, y equals 3, the line and the y-axis. And we can now rotate that about the y-axis. So formula for that, volume is equal to pi integral between 3 and 2 x squared dy. So if you change over your x's and y's, then you'll rotate about the y-axis instead. Just watch this algebra here, just trying to get you into good habits. So if I rearrange this, because I need to substitute in terms of y, then this here means that x is equal to y minus 1 over 2. So this volume is equal to the integral of y minus 1 over 2 squared dy. What I would suggest doing, we'll do more of this as the course progresses, but you can split a power across a fraction. So that will give you y minus 1 squared over 2 squared, which is 4. And then you can pull this quarter, essentially, out of the integration. So that's equal to pi by 4. So if you're multiplying an expression by a constant, it can come out, and it just makes the integral that bit easier. So that now I can just integrate y minus 1 squared. So y squared minus 2y plus 1 with respect to y. I'll leave that with you from there. I thought I'd written down the answer, but I haven't. But that there, you integrate this times by pi by 4, and then you'll get an answer from there. Hope that's clear. Any questions, obviously, let me know.